Hi, I am Chandrasekhar Gupta and we are discussing programming concepts. Before discussing today's topic, suppose for example, Amazon came and hired you. They want you to write and develop a script such that their complete tech support is taken care. You will be receiving phone calls continuously and you will be having limited set of resources, the people who can assist to the persons who are making the phone call. What you need to do was, you need to develop a data structure or you need to use a software such that the people who are calling will be more in number than the available number of resources or the available number of people who are provided to support. So, what is the data structure that you can use? We can make use of queues. Let's try to understand queues with one more practical scenario. Let's take a situation to understand queues. Suppose you are a person who is responsible for distributing chocolates for an event at your school. You asked all the students to form inside a queue. We have 5 students in the queue. They come, collect the chocolate and then they leave. As a computer science programmer, you thought of a way to replicate or simulate this situation inside the system, and you thought it can be done with the help of a queue. How it can be done with the help of a queue? Generally, when you have these people inside the queue, is if some new student is trying to enter, he enters at this end, and if student is leaving, he is leaving at this end. So we need to keep a track for entry and for exit as well. This is at the end of the queue, which can be maintained with the help of a rear pointer. This is at the start of the queue, which can be maintained with the help of a front pointer. So if you have a queue, it will be having 2 pointers, front pointer and the rear pointer. Insertion happens at the rear pointer. Deletion happens at the front pointer. If we just observe carefully, queue can be implemented with the help of an array, or it can even be implemented with the help of a linked list. To understand the implementation of the queue, let's take the previous example. We have the students who are standing inside the queue. We know that insertion happens at this end and deletion happens here. Insertion in queue is called NQ and deletion can be termed as DQ. We all know that at the front you are having a front pointer which looks after dequeuing or deletion. At the end you are having a rear pointer which will actually look at insertion or enqueuing. Let's try to understand its implementation with the help of an array. Suppose we are having an array. You are having a front and rear pointer initially. So when you want to insert, let's say 1, you increment the rear pointer, you insert the element. Similarly, if you want to insert 2, again you increment the rear pointer and you insert the element. Now, if I want to delete the first element, I'll increment the front pointer, I'll take this element and then I'll increment the front pointer again. Now this will be out of scope. So deletion and insertion is happening with the help of front and rear pointers by incrementing and by taking the value at that respective position of an array. After understanding the crisp concept, let's try to give an insight to it. Consider an array. Initially, the front is pointing to 0th index and rear is pointing to -1. Now, to perform NQ operation, I need to increment the rear pointer and then at this position of the array. Let's say the array is named Q. At this position of the array, I can insert whatever element, let's say 1. So, initially, I am going to increment the rear pointer. This actually makes the rear point to here and it changes the value to 0. Now, this can be accessed with Q of 0 in case Q of rear. So, Q of rear is equal to the item which you have to insert. Let's say in this case 1. So, 1 has to be inserted in Q of rear. 1 will be inserted here. This happens at the NQ basically. But there are some of the conditions which you need to check. Suppose, for example, if the array or queue is completely occupied in this case, let's say the queue is completely occupied. Now we know that the rear pointer is actually at this point and front is at the beginning of the array. Now you are trying to dequeue. That means I need to get this element and I need to increment the front pointer. So let's say I am taking it to an integer k, q of front. So k will actually be having 1 in this case and then I need to increment the front pointer also. So front plus plus. This will actually take the front pointer to this case and I repeat this operation. So I have dequeued 1, 2, 3, 4 and let's say the front pointer is here. And if I want to dequeue further, front will actually try to access a memory location which has not been initialized by the array or it is out of bound. To prevent this situation, we'll try to implement queue with the help of a circular array. If we just observe this scenario, we need to make a step such that a number has to be produced in cycle. If you consider 1, 2, 3, 4, 5, it has to be repeated and produced in the same cycle, which can be achieved with the help of modulo operation. Let's consider a situation where the size of array is 5. If I take an index, let's say friend. So friend is initially pointing to 0. I want friend to be incremented by 1. So friend is equal to friend plus 1, but I am taking a modulo operation with its length in case n. Now friend is initially 0. I am trying to increment with the modulo operation. So now 1 mod 5 will be 1. If I increment it further, 2 mod 5 will be 2. 3 mod 5 will be 3. 4 mod 5 will be 4. Now if the friend pointer is here, let's say the friend pointer is here and you are trying to increment it further. So you are trying to again perform f is equal to f plus 1 modulo n. Now 5 mod 5, which actually turns to 0, which means the friend is actually going back to its initial position of an array as if it is circular. So circular array can be implemented with the help of this operation. Just perform the addition and modulo operation with its length. Let's consider an example. Initially, the rear is pointing to -1 and front is pointing to 0, and this is the array Q. Now I want to NQ 1. So when I want to NQ 1, I'll actually increment the R. So R will be incremented to 0 and it should be equivalent to 1. 1 is stored here. Similarly, I have incremented R and let's say 2, 3, 4, 5, 6. I have stored it respectively and the rear is here. Now if I want to increment or if I want to NQ it further, I cannot do it because the array is completely occupied. So you need to understand that why this in one way, this example actually gives the importance of dynamic memory in one way or other. That is, if we are running out of space, dynamic memory actually instantiates some new space and allocates some new memory locations so that we can store it according to our need whenever it is required. But in the case of array, it is static and the size of the array or the memory that has been allotted is fixed. Now, in this case, when you are trying to implement with the help of an array, then you need to keep track of length. Let's say the length over here is 6. You need to check whether if rear pointer is pointing to length -1. If it happens, then the array is full or the queue is full. You can print and you can actually tell the user that queue is completely occupied with storage. In this case, if you want, you can perform dequeue operation so that the queue will be free. So to perform the dequeue operation, you can actually increment the front pointer. 1 will be gone and it can be utilized. Similarly 2, 3, 4, 5 and 6. When front and rear both are equal, you need to understand that array is completely empty. When front is equal to rear, then array is completely or queue is completely empty. You can take this analogy and you can look after the various situations where queue becomes empty or where the elements can be inserted or when the elements can be removed. All of these situations can be analyzed and can be studied further. That is about queues, NQ, DQ, all the operations, circular array implementation of queue and everything. Now, before winding off, we have implemented and talked about functions, how the functions have been working and a lot about it already in detail. But everyone is familiar with a term called as recursion. It's a kind of nightmare because we don't tend to understand how it is being executed step by step. So, in our next tutorial, we'll try to understand recursion and iteration in detail.